My name is Ishola Kayode, and I'm with the team at KidsTech Africa. We have our team lead, Dumoya Yobami, Bolaro Adegoke, and the rest of the team right here. I'll be introducing our keynote speaker, Mr. Rahul Pandey. Today, will be giving us insight about opportunities in coding for kids. KidsTech Africa, it's an Africa technology company. We are an edtech company that we are into we give opportunity to young people between the ages of 6 and 15 to explore the world of technology by teaching them hands-on coding. We've started in 2019, and so far we've trained about 2,000 kids across 2 states. And this evening, it's 7:35 p.m. here in Nigeria. Mr. Rao, it's about 11:35 in California, right? Okay, here. So we are excited to have you. Okay, so we are excited to have you. So without much okay. Yes, you can speak. I can hear you.
Okay, yeah, let me dive into it. Yeah, so thanks so much for hosting this short session. I can give a bit of an introduction about where I am and where I'm coming from, and then I also have a few comments about a few thoughts I have about getting kids into coding and the importance of that. Should I just dive into it, or is there anything else that you want to cover before we?
Yes, I just want to read your profile, then we can get right into it.
Yeah, sure.
Okay. So today we are having Mr. Rahul Pandey, who is an engineer at Facebook and Facebook portal and lecturer at Stanford University. He's also an Android tech lead and instructor. Mr. Rahul is an Android engineer at Facebook portal, an Android-based audio and video conferencing device. He also spends a lot of time teaching Android development as a lecturer at Stanford. And he's also, he has a YouTube channel focused on tutorials and tech career growth. Prior to Facebook, Rahul was an Android developer at Pinterest. Outside of work, you can find Rahul playing tennis and pickleball. So, ladies and gentlemen, we have Mr. Rahul Pandey, and we are excited, so excited to actually have him tonight. So, Mr. Rahul Pandey, you can begin now. Thank you.
Yeah, appreciate the intro. Yeah, like you mentioned, it's 11:35 here. I'm in California right now, but I have the day off work, so I'm able to kind of spend time with all of you. And if people have questions or comments at the end, I'm happy to answer anything if I can help. But I wanted to just comment on some of the work that you all are doing, which I think is really important. So you mentioned how you have 2,000 kids who you've helped teach and train in coding so far in Nigeria, and you're expanding to other countries. I think that's amazing work. I think there are kind of 2 reasons why that is so important. One is that I think that for the first time, it's actually possible for children, people who are maybe 10 or 12 or 13 years old, quite young, to actually start to build meaningful skills in programming and coding. And the reason for that is because the cost of developing something keeps going down, and that trend will continue, right? So if you look back at history, maybe 30 years ago, then in order to get a website up and running 20 or 30 years ago, it was a huge pain, right? I had to figure out how I can connect my computer to the internet, keep it running all the time, run some software on it, and then it required a bunch of infrastructure, and I'd have to learn a lot, right? So for one person to put a website up, it was very hard to do. But then in the late 2000s, like 2009, 2010, you started having services like Heroku or AWS, where you could basically, using just my computer, I could deploy software on the cloud. And that made and also a lot cheaper. And now you have things like Android and iOS mobile apps, where I could write an application in one weekend, and then I could deploy it, and millions of people could download it in the next week. And so you can see the trend happening where before you needed a team of 10 people in order to get an app built. And then 10 years ago, you needed a team of maybe 2 or 3 people. And now you can actually do you can actually build a full app or a full website within one weekend with one person. And so I think the amount of value that you can unlock as a developer is increasing every year, which means that 5 or 10 years from now, the power of a developer, the power of a programmer is going to be huge. Like these jobs are going to have so much power and so much importance. So I think being able to teach the children about this skill set is very, very important. So I think that's really important that you all are doing that. I think there's also a second reason why this is really important is because technology needs representation. So more and more of our lives are becoming powered by technology, right? So we use our mobile phones many times, many hours a day. I don't know, people here, do you, if you use like voice technology, where you say Alexa or Google and you talk to it and you're able to, get answers back, right? So a lot of our lives is being powered by this technology. And so have a certain type of person who's building up this technology, then you will actually leave people behind. You'll leave people out. So for example, if there were no people of Indian origin or African origin who were developing Siri or the Google technology, then most likely the technology wouldn't work as well for people of darker skin, right? So that's the reason why I think being able to learn this technology and contribute to it, not just consume it, create this technology, that becomes increasingly important in a world where all of our lives are being dictated or controlled in some ways by this technology. So as the world becomes more and more AI focused and technology focused, we need to make sure that people from all different parts of the world are able to contribute to that productivity and technology improvement. So those are kind of the two things I wanted to mention. One is that the cost of creating technology is getting lower and lower each year, and it's also easier every year. So we need to make sure that people are aware of that and able to learn it. And the second is that as more and more of our lives become centered around artificial intelligence and technology, we need to make sure that people from different parts of the world, different genders, different nationality, different ethnicities, all of them are able to contribute to the technology. Otherwise, it's very easy for the technology not to work for people like me and you. So we need to make sure that we're all able to contribute to that. So those are two of the thoughts. I also had a few thoughts on how to practically get started with, teaching coding, because I've been doing that a lot. But maybe I'll pause there and see if there are any comments or questions at this point.
Yeah, it's been very, very great. You mentioned the fact that everybody must be carried along, every continent, everyone from different continents, from every country, so that we can domesticate the technology. You mentioned Siri and Google Assistant. In the last few years, there has been an upsurge in the ways people adopt voice assistants. And in fact, now we have smart homes, we have smart gadgets that are connected. And this, we usher in a whole lot of technology that will drive this stuff. So you've really, really shared a lot of insight. I also want to ask about the languages that you feel will be relevant. At KidsTech Africa, currently we've adopted Scratch, although Scratch is not really a programming language, but of course for beginners, as young kids between the age of 6 to 9, we feel having to do a lot with block-based programming languages. We do a lot in stimulating their interest in then doing the proper coding. So we've adopted Scratch, Python, and then also on Java. Then recently Arduino, because we understand that Arduino bots is also one of those things, like it stimulates interest in going into electronics. So what are your thoughts about programming languages, and what are the languages that you feel will still be relevant in the next few years to come?
Yeah, that's a great question. So I think that starting with technology like Scratch or Arduino is really great, because Scratch is designed for beginners. It's designed for people who may not have a very extensive coding background. So I think using that is a really good on-ramp into getting deeper in programming languages and technology. And the benefit of something like Arduino is that it's hardware, right? Like Raspberry Pi or Arduino, oftentimes when you have when you have something tactile, I can actually touch it, I can play with it, it becomes a lot easier to feel like it's tangible, and I get more excited by it compared to like something on a screen, right? So if I'm a kid, having that hardware component actually becomes quite important. So I think those are both really good places to start. I think that some people will start with, for example, I do Android. Android is a pretty good place to start with learning technology, but it can get quite overwhelming, right? The issue with Android is that the software to build Android apps is used by people who have 10 or 20 years of experience programming. Like these are experts in what they're doing. And so the tooling around Android is actually very, very advanced, and 95% of it will not be relevant to a beginner. Is with, going into iOS or Android development, is that the skill set of people who do that is huge. You have people who have just started programming or who are doing Android, and you have people who have been programming their whole lives, and they're also doing Android. And so that means that it can very easily get overwhelming or confusing to a new student if you're trying to do something like professional or like, an actual Android or iOS app. So I think for the first few months, if the student doesn't have any experience with programming, I think that Scratch and Arduino, like something like very tactile and very approachable, is a very good option. And then once the student has more experience, then I think jumping to something like Android is a really good option.
Okay. So that's impressive. So can you share about tell us about your story? What motivated you to learn coding and your exploit in the technology world? Because we've worked at like many of these big companies, Pinterest, Facebook. You're also a lecturer at Stanford. So we want you to really tell us about your story, what stimulated your interest and that.
Yeah. So I I went to Stanford as a student. And I think prior to Stanford, I really didn't have that much experience in programming. And so what really got me into the world of programming and learning technology is going to Stanford. And Stanford is located in Silicon Valley. And so you have so many people here who are focused on building a startup or using technology in order to do some kind of hack or do something interesting. And so when you're around people like that, it's very easy to start getting attracted to the idea that you can also build something just like they are. So I think a lot of my initial motivation to do programming was just like, hey, everyone else around me is doing it. Let me also do it too. And so I started programming like, early in my Stanford career. And then I kept basically learning different languages. I think for the first 2 years, I was not good at all. Like it just took me forever to figure out how to debug anything. It took me forever to figure out how to set anything up. But I think once you do it enough, once you keep trying, keep failing, then at some point it becomes much faster. And so after 2 years, so then as internships, I know how to use the technology that I've learned and actually use it to create business value. And so then after Stanford, I joined a startup, and that startup got acquired by Pinterest. And then at Pinterest, I started doing Android development. And that's also where I started teaching. So one of the things about technology is that it changes so quickly, right? So as soon as I started my job at Pinterest, I noticed that, hey, I actually have some ability to teach people about what I've learned. And the other thing about teaching is that you can actually, regardless of where you are in your career, your perspective will have value. So let's say you're a 15-year-old. So you're still fairly new to programming, most likely. But as a 15-year-old, the way you might explain something is going to be different compared to how I might explain something, right? Because like our approaches, like our background in programming might be a little bit different. And so the way a 15-year-old I explain it, because I'm really value in everyone teaching. So I think I really would encourage everyone, like if you have the opportunity, start tutoring, start being a mentor to other people, start publishing videos on YouTube, do whatever you can to teach, because I think you also learn a lot in the process. But starting from Pinterest is where I like basically every week or so, I would just teach something. And that continued on when I got to Facebook. And then that also led to an opportunity to teach at Stanford. And so I've been teaching at Stanford now for a little bit more than a year, which has been really fun. I just teach the introduction to Android class.
Okay. So you teach Android development at Stanford.
Yeah, that's right.
So what are the early challenges, like the major challenges you faced learning, like when you jump started your career as a programmer?
Yeah, so you're talking about when I was learning programming, right? Not teaching programming?
No, when you were learning.
When I was learning, yeah, okay. So when I was learning, I think the main difficulty was that there would often be times when I wanted to do something quite simple, which I thought was simple, but I would end up getting stuck on that for hours and hours. And so that can get really demoralizing. Like, for example, I have a program and for whatever reason, it won't compile. And I think, oh, like I just changed like a few lines of code, but it won't compile. And then it's very easy to actually get stuck on that for 2, 3, 4 hours. And unless you have a support system around you, unless you have someone you can ask for help, or unless you have some sort of teacher or mentor, it's very easy to give up. And so I think one of the things about, being in a school is that you have the ability to like go down the hall and get help from your classmate, or be able to go to office hours and ask for help. So I feel like as long as you have that support structure, you can overcome those, but everyone is going to face that challenge. I'm stuck and I don't know what to do. So like being able to know where to look for help is really important there.
Okay. So looking at the direction of teaching kids in coding, like I earlier asked a question about the programming languages that we've adopted at KidsTech Africa. Now, do you have other recommendations like programming languages that can be tailored to fit in with the demands? Because looking at here, there are a whole lot of technology deficits that we have to deal with. Take, for instance, maybe gadgets and some other stuff. We're still coming up. But looking at that, with that in mind, do you have other programming languages that you can also recommend for parents and for kids that are just planning to go into coding?
Yeah, I think it's a good question. And my answer is actually a little bit of a non-answer in the sense that I don't think it's worth spending time trying to predict what technology or what language the kids should learn. Because here's the reality of the situation is that if we're teaching kids coding, which I think is great, like you were teaching a 15-year-old or these younger people to code, in 20 years or 10 years, when they actually get their first job, the world will look very different. The languages that they use when they get their first job may not even exist today. And so I think it's actually not that productive, in my opinion, to try and predict, okay, this language is going to be popular, so let's start teaching the kids this language. I think what's more important is let's get people excited about technology. Let's have the kids understand what is a for loop? What is a data structure? Like, what are these basic constructs of programming? And once you understand that, you can apply that to whatever technology you're going to use. Because the reality is, at the pace that the world is moving, every 2 years, every 5 years, the technology that I use or you use is going to change. And so rather than trying to predict what technology will be used in the future, which may not even exist yet, the more important thing is let's get people excited. And I think the reason why Scratch is good and Arduino is good, or maybe Python is good, that those are languages which are actually very easy to get started with. And once you get started, you can start to learn more, and you can take that skills that you learn and apply it to whatever else you end up doing in the future, because who knows what will happen in the future. We can't really predict that.
That's impressive. There's a question on the forum. Someone, Samson Adegoke, is there any disadvantage or disadvantages for introducing kids to coding? That's his question.
Yeah, my answer here is no. I really feel like, the only reason there could be a disadvantage is if we feel like the time that the kids are spending learning coding could be better used in learning some other subject like math or, history or language. But I feel like it doesn't have to be a choice between those. Like, it's very easy to, I think right now, a lot of the education is the same as what it was 50 or 60 years ago, but the world has changed in a very big way compared to 50 years ago, right? And so the fact that our education system has not really kept up, I think is a failure. And I feel like we really need to go much deeper in coding, or at least introducing the concept of computers and computer literacy much earlier on than we already are. And I think one thing I'll comment on here is that some people might say, you know, I might not actually be coding full time. I might not be a programmer as my full-time job. I might be a chemical engineer, or I might, you know, do something with automotive. I might do something with mechanical engineering, right? I might not do programming. But my prediction is that in 10 or 20 years from now, every single job is going to require some amount of computer usage. And so actually the way to think about the world is not that, oh, I'm going to become a software engineer or not. You should basically think about every job in the future will be a software job with something else attached to it. So whether you become a chemical engineer or a mechanical engineer or a computer scientist, all of those jobs will require the use of a computer in order to do something faster or more efficiently, right? And so I feel like there's really no disadvantage of teaching kids coding, because as technology becomes more and more embedded in our lives, we need to have the awareness and know-how of how to use it or change it with whatever we end up doing, even if it's not a full-time programming job.
Thank you. That's very impressive, because I really agree with you. In the last 5 years, even here on the African continent, we've seen a whole lot of adoption of technology. Take, for instance, there's this general exam that is very mandatory if you are going to go into any tertiary institution in Nigeria. We call it JAM, Joint Admission Matriculation Board. Now, that UTME exam, that Unified Matriculation Tertiary Education exam, it requires, now it has been migrated into a CBT exam. So whether you know how to operate a computer or you don't know how to operate a computer, it is very mandatory. As long as you want to go into any tertiary institution in Nigeria, you must write that exam. So for kids that are not really immersed in the idea of, like, maybe in that doesn't really have even know the basics of operating computer, is a challenge. So I know some people are technophobic, and immediately, despite the fact that they even know the right answers to the questions, it will be difficult for them, because immediately they are sitting in front of a computer, they start to panic. And so in the next few years, there will be more and more adoption to everything. Now we now have universities that offer degrees, like full-blown degrees on that is virtual. Almost everything, you have to do everything virtually, like online and all of that. So there is going to be more. So I still have like two other questions here. Okay, there's a question here saying, Oluwatoyin Abayomi, is there any way that coding affects a child's academics? That's the question from Oluwatoyin Abayomi.
Yeah, I mean, I think if there is any effect, it will be a positive effect, because once you really start to do a lot of coding and programming, I feel like it'll actually make you it'll make you better at math. It'll make you better at science, because programming forces you to be logical, right? Like, there's no arguing with the computer. If a computer says that your program is incorrect or it's not doing what you want it to do, you have to fix it. So I think programming actually creates a lot of discipline, in that you have to be very precise about what you're writing and how it will be interpreted. So I feel like, if anything, it'll be a positive impact on, you know, other fields of study. And actually, one thing I wanted to also mention, like going back to what you were saying, is that, like, people are technophobic. I think that's the problem. If you're technophobic and you're afraid of sitting in front of a computer, you will be left behind in 10 or 20 years. Like, there's no way around it. The world is going in that direction, and you need to know how to use a computer. So that's why it's even more important for children who are just coming up. They need to know how to use that. Like, one example I can give you is, my dad is a mechanical engineer, and his job, he's been at the same company now for like 25 years. His job has completely changed in the last 25 years, where it was primarily paper-based, to now his whole job is on a computer. And so for him to say, oh, no, I don't want to use a computer, he would be out of a job. And so I think that's going to happen increasingly. So we need to make sure that people are aware of how to use a computer and how to work with it, how to debug it if there are issues, because every part of our job will become important. And I think that's, going back to what I was saying earlier, we need to make sure that people are represented in tech. So for example, if the reason that you can't use technology is because something is confusing to you, maybe like it doesn't make sense in your country, like that icon is confusing, then that is another reason why you make sure that people from all walks of life, whatever gender, whatever country, whatever nationality, you should be the person who's developing the technology, because then you'll make sure that it's actually
Works for you.
works for your people. So I feel like that's another reason why we need to encourage people to get into technology.
That's really, really impressive. I think there's still another question from okay, what is the best teaching techniques to adopt in teaching coding to make the kids get addicted? I don't want to addicted to coding environments. Maybe let me say, I don't want to use the word addicted, but maybe excited to coding environment. That's the question from, that's our team lead, Dumoya Yobami, is the team lead for KidsTech Africa. So that's this question, like, what's the best teaching techniques to adopt in teaching coding to make the kids get excited to coding environment?
Yeah, I think it's a great question. I agree. I think addicted had like a negative connotation, but like that's excited, like we want people to be really enthusiastic and passionate about coding. So I think the way I approach it is something called low floor, high ceiling. And what that means is you want to give the kids enough structure that they know how to get started and how to meet a minimum requirement that you set. So for example, if you have a program, you could maybe give them some of the starter code. It's okay, here you have to fill out this function and it has to output this certain output when I give this input, right? Like you have to give them some instruction. But I think the really valuable thing to make kids really love it is you want to give them some freedom. It's okay, once you've done that basic requirement, then you can actually go above and beyond that and create something on your own. You can kind of modify the program in any way you want, or you can extend it in a certain way and give them some framework to do whatever they want beyond the basic. So that way, the student knows, okay, I've done the bare minimum, and now I can actually go even further. So that I think has worked out really well when I teach, and I think a lot of kids will be excited to go further when you give them that freedom.
That's nice. Then there's another question from Dr. Sandy Popola. Mr. Rahul Pandey, Dr. Sandy Popola has been a very instrumental personality to our growth here at KidsTech Africa. Last year we held an exhibition in Nigeria where we have kids that worked on different projects. Take for instance, one worked on an ATM simulator, another worked on the tic-tac-toe using the Python programming language. We also had some of them that developed games. So Dr. Popola was very instrumental to our getting the UNESCO backing for our programs here in Nigeria. So he asked the question, I encourage my children to learn coding instead of playing games, but wonder if they can be addicted to coding just like they do to playing games online. What advice can you give to prevent them into being addicted? I think he's talking about getting kids to learn coding instead of playing games so that they can be more excited with coding like they do with playing games. So he's also asking that what advice can you give to prevent them from being addicted to games, like gaming?
Yeah. I mean, so I think first off, I'll say that a lot of my coworkers and my colleagues, they actually got into programming because of gaming. So I think that, of course, if you do gaming like 12 hours a day, that's probably unhealthy. You don't want to do anything to that extreme. But I do think that if your kid is wanting to do gaming, that's actually okay, because oftentimes the next logical step from doing a game is like, how can I change the game, or how can I modify the game? And the way you do that is typically through coding or programming. So gaming can be a good on-ramp into learning more about technology and learning more about programming, but you don't want to do it too often. So I feel like that's the first thing I'll say. And then in terms of like how to prevent addiction in either gaming or coding, I feel like the key thing here is you need to have checkpoints to make sure that the student is actually on track. Like there's a productive way to spend your time and there's an unproductive way. So as long as you have some certain benchmarks, it's okay, here's what I want you to achieve by this date, and you kind of make sure that you're checking in with them, then I feel like you can at least make sure that they're not going and wasting too much time in something that's not really important, and that you're able to guide them appropriately and give them feedback as needed. So basically the key thing here is just make sure that you're keeping in constant communication with the kid.
Okay. Thank you so much for that. Okay. Yes, Ajakaye Damilola is asking the question, how do you make coding fun for kids?
Yeah, I think there's a couple ways. One is that I think having something visual is important, because actually having images or colors move on the screen is always going to be more fun compared to like having some text. So that's where like Scratch, which is very visual and drag and drop, that is really good. Having something tactile where I can actually touch it, some hardware, Arduino thing, that is also really important to make it more fun. And I think the other thing is just ask the kid what they want. Like if your child is really interested in, hey, I want to learn more about, the clouds and like the color, or like, something about nature. Maybe you can do a programming or coding exercise, which uses something with clouds, or like does some sort of computation about how clouds and water work together, right? Like you can basically try and match the similarity of what the kid is interested in and embed that into programming. So I think that's probably the few top of mind things that come to mind.
That's impressive. Thank you. So I want to read these comments from, I think Mobolaji. Programming also increase a child's knowledge on maths, English, science. Okay, to understand programming, you have to have the mind of a scientist. It is so exciting and interesting. It is basically logical. It's like a puzzle. That's the comment from Mobolaji. Now, Olawuye Abdul is asking this question: what is mentorship approach? Okay, what mentorship approach do you recommend in the training of children in coding or ICT world?
Yeah, I think the mentorship approach is, I guess maybe I'm helping understand. So when we talk about mentorship approach, are we talking about like how to train students most effectively?
I mean, like maybe perhaps it's talking about like the approach to training of children in coding, like what kind of training approach that we should recommend?
Yeah, I think there's a couple of things. One is that I feel like having these frequent check-ins with the teacher and the student is important. And also having some interaction with the student is important. So I feel like sometimes the way I explain something might not make sense, but if another student explained it to someone, it could make a lot more sense. So having some sort of interaction between students and having some sort of pairing, I think that can become really powerful. And I think the other thing is what I talked about earlier, which is give students an opportunity to have freedom to do whatever they want and then get feedback on their work. So like having some sort of feedback loop or feedback cycle, that becomes really important. Either the feedback can be from a teacher, like one of us, or it could be from a fellow student. But like having that sense of like working together and getting feedback, I think is really important for mentorship.
Okay, that's impressive. Someone is asking, how was coding invented? Was it invented through mathematics? That's the question from one of the participants.
Oh, nice. Yeah, that's an interesting question. How was coding invented? I mean, so if you look back in the history, I think coding started out as a way to do challenging mathematical operations, because humans are not very good at crunching numbers, right? We're not very good at computation. But if you have a computer and it's a series of zeros and ones and you can do some sort of arithmetic, it will never make a mistake. And it will always be, it'll be incredibly fast. So I think coding was invented as a way to say, hey, we have this complicated formula or the complicated algorithm, like this complicated math equation, and we want to be able to get answers on it very quickly. And let's offload that work to a computer. And now the question is, how do you communicate to the computer what is the formula or the math problem you wanted to solve? And that is really where I think the origins of coding began.
Okay, that's very impressive. So while we wait for maybe some other few persons, because our time is fast spent, and you've really been very insightful and helpful, because if I've learned a whole lot today talking about how we can stimulate people's interest with coding. I'm also a gamer. In fact, about 30 minutes ago, I was still on my PlayStation console trying to and one thing is, the first time when I played PlayStation 3, of course, I've been a fan of PS2. I know PS2 is one of Sony's most successful gaming console. Now, when they introduced PS3 with very killer graphics and all of that, I was extremely excited with it. Now, when in 2018, prior to the 2018 World Cup, they released this PES 2018, and with the graphics and with the commentary, Jim Beglin and this other guy, and all, because I'm a soccer, I'm a soccer person. So
Yeah.
it stimulated my interest. I was like, what kind of game engine was used, like the development that was used in developing this kind of game? So it's something that really stimulated my interest. That was what led me to working on there's this particular, is this Sandbox 360 or okay, there's this game engine that I worked on at that time. So I started researching about it. Then I got to know a couple of things about how the PS3 or the PlayStation console was developed. And it's one of, had it been, there's the technology that of course I could collaborate with other people that are also excited in that area. Then perhaps maybe by now, maybe we would have had our own version of of a PlayStation. So it's really good and it's really insightful. Like when kids play games or they interact with computer, with gadgets, it makes them to really think big. And for the ones that are very creative among them, they will be able to think about how they can create something similar. That of course there's this excitement with creating your own game. Imagine creating your own game and you're playing with it. So it's really cool. Now we have a question from Mojonyola Adewoye. Now she's saying at one point will it be okay to pair children with people that write real programs and the live application of what they've been learning?
I think the answer is that it will depend on the student. So like when you start out, working with a computer can be quite overwhelming because there's so many different things that can go wrong. You have to understand the error messages. You have to understand how to debug issues. So I feel like probably for the first one year or so for young children, I would not recommend actually trying to build like a real, like, you know, the soccer game that you had mentioned, or like something more complicated. You should keep going in the realm of Scratch and Arduino and like build kind of toy things. And then once you feel like the child has enough knowledge and enough ability to debug things, that is when you can kind of graduate and start building real applications. And I think in terms of what those real applications are, they could be, you know, a game. So there are things like Unity or Unreal Engine. I'm not sure if you've heard of those, right?
Yeah, Unity.
But
yes.
Those are, yeah.
Yes, I stumbled upon it when I was doing a research about building games, like 3D games.
Yes, exactly. Yeah. So a lot of the mobile games, at least, are built from Unity or Unreal Engine. And so I think if your child is interested in that, they could go on that approach. Or if they want to do kind of mobile app development where you just build a normal application like Twitter, then you could also start doing Android or iOS development. So I feel like the answer is that it will probably depend on how advanced or how proficient is your child in coding. But the thing is, like, once you get to that level, it becomes a lot harder to get help. The error messages might be a little bit more hard to understand. It might be harder to like make progress. So I would recommend staying in the world of Scratch and these other technologies, the beginner technologies, before you go too quickly into that world.
Okay, that's impressive. So on a final note, I also want to ask about what are you currently working on, like your projects, like because the first day when we actually have a conversation and that our team lead also interacted with you, and we were very excited because we went to your YouTube page and we saw what you've done, what we've covered, and your portfolio. So right now, what are the final, like before going to the final, your final thought, also like your project, what are you working on at the moment, like as a programmer?
Yes. Okay. Great question. So I've been so I know, here's how I spend my day. I have a lot of my time goes into my day job, which is, I work at Facebook. And then I also spend some amount of time making YouTube videos. But I think the remainder of my time goes into thinking about this problem of how can we get more people excited about programming and excited about tech. And in particular, I think the area that I'm interested in is how can we get students to feel confident about getting a job as a software engineer if they want that. And the reason I think that's important is because a lot of people will not or cannot go to Stanford or MIT or one of these top universities, right? It's like one of the things I think about is even if you go to some school in the middle of the United States, or even if you went to school outside of the United States, how can I make sure that you have the ability to demonstrate your skills in order to land a job at any company you want? So like if you want to work at Microsoft, for example, or if you wanted to work at Sony, for example, right? Like I want it to be possible for anyone in the world to be able to apply for that job at Sony and be considered for it, rather than it only be something that people in the United States can do. So I've been thinking a lot about how we can make that happen. Because the thing is that, coding is universal. If you create something which has value to people, whether you do that in India, or whether you do that in Nigeria, or whether you do that in the US, it still is very valuable. So like, how can we identify people who have done that and get them the jobs that they deserve at whatever company they want? So that's kind of a problem I've been thinking about a lot.
Wow, that's very impressive, because also there comes the question of when people learn coding, a lot of people have been saying, okay, yes, I've learned coding, I've developed the skills, then what next? So
yeah,
that's always been a challenge. But from my own perspective now, one thing that I've really realized is just that a whole lot of people that learn coding also need to understand the concept of entrepreneurship. Of course, problem solving skills. As soon as you're learning coding, you should also identify projects or things that problems you could solve, particularly in your community, maybe in your country or whichever, such that you can now use the knowledge of coding to develop, like solve those problems. Then you have created an avenue for you to also make money and also get things in place. So I feel as we are also learning coding, particularly because it's one of the approach that we've adopted at KidsTech Africa, we understand that learning coding alone is not the only thing that we should also focus on. We should also identify problems that are peculiar to, like one of the participants of our program last year, Ibrahim, after he worked on a CBT software, he built a CBT software. He's a 12-year-old kid who participated in the program. Now, I think at that time, there was a day we were interacting with him when he came to our workspace. So he said that he identified that his dad who has a fish farm, and that he couldn't get access quickly to the veterinary doctors. So then he was thinking about developing a software or like a platform, like an app that will connect farmers with veterinary doctors, or as that case. So it was something that was very, very impressive to us, because we were looking at it from the perspective that if a 12-year-old can think in that direction. So learning coding is cool. Then also we must also be able to identify problems that we can solve with the Facebook. The Mark Zuckerberg, of course, we work at Facebook. When Facebook started, it was a problem. Of course, connecting people at that time was not as easy as it is now. Of course, they solved the problem with their coding skills, and now we are here and all of that. So those are some of those things in which we can talk about. So our one of our partners, Mrs. Mojoyin Olawoye, so she's making a comment here that programming also talks about the structure of the human brain. It is like teaching a baby, and like a baby taking its first step, just like creating a digital speech or realm and then imputing your own ideas with your own formula. It is like creating data blocks, and that is very impressive. That's Mrs. Mojoyin. Mrs. Mojoyin she has been very, very instrumental to the development of our curriculum and our corporate structure here at KidsTech Africa. Then also, I also want to recognize and also introduce one of our mentors, and he's also one member of the advisory board at KidsTech Africa, Mr. Jimmy Diago. So I'd like him to say one or two things, then to also meet with you, because he's based in Dubai, and he's also a global tech person. He currently has been doing a lot in the blockchain technology sector. So Mr. Jimmy Diago, please, I want you to really meet Mr. Rahul Pandey, our keynote speaker today.
Hi, Rahul.
Hey, how's it going?
Yeah, I'm very well. My name is Jimmy Idiabo, if you can pronounce that correctly. And it's so nice to meet you right here on the Zoom call. I've been really looking forward to hear from you and to see how we can tap into your wealth of experience, knowing that you've had some very good time at Facebook, if I'm correct with the information I received then. So, I mean, this is quite a very interesting program for me. I had to create the time to make sure I participate in this Zoom conference, and we look forward to see how we can synergize with you and your team at Facebook INC. I'm very familiar with the Facebook ecosystem. We also have our own establishment somewhere in St. John's in California. Actually, we're trying to set up something there. So I hope we can build a mutual relationship and see how we can actually attract more knowledge based on the tech space in Africa precisely. That's my own core area of interest. And that's it. So far,
Yeah.
I think the KidsTech team, they've been doing a very incredible job. Fantastic ideas that Kay and his group came up with. And I hope that they can actually improve and more scope on their products, which I've really been discussing with them. Because I know there are so many other kids out there in the Caribbean and Asia continent and some parts of the Oceanic and Pacific as well. I travel globally, so I have a brief of idea of what challenges each country goes through. And KidsTech, I think they can go beyond Africa and see how we can actually extend the knowledge of tech in the younger generation. So once again, it's a pleasure meeting you, and I appreciate you creating your time to see how you can put things together for us. We appreciate that. Thank you so much.
Yeah, no, my pleasure being here. Nice to meet you as well. I think this is really a worthwhile mission that all of you are pursuing to get kids involved. So whatever I can help with, I would love to keep in touch.
Oh, okay, that's nice. Thank you, everyone.
So thank you so much, Mr. Rahul Pandey. Please, we know a whole lot of questions and all. You've really been so insightful. So for people that are just joining, this is Mr. Rahul Pandey. Mr. Rahul Pandey is an engineer at Facebook and a lecturer at Stanford University. He has done a lot in the tech community. He's an Android developer, and one exciting thing about him is he loves to motivate people and to make people see opportunities that lies in the world of technology and coding. So we've been getting some questions. Of course, some of those questions are repeated. So we're going to upload, since this session is recorded, so we're going to upload it on our YouTube page. So we'll share it with people so that they can get to see those places where you answered some of the questions that are still popping up, so they can get to see it and get their answer. So I would like you to give us your final thoughts before we end this session.
Yeah, so thanks again for having me and for hosting this session. I think that in the past 10 years alone, technology has become so central to every single day, every single hour of our lives. And that will only get deeper and deeper. More and more technology will be embedded in our lives. And so getting the younger generation involved in coding, involved in technology is extremely important, especially to make sure that we have inclusive products and the things that we build in the future will work for everyone. So I think that the work that all of you are doing is amazing, and really happy to be here. And I think that let's keep going and expand the reach to as many people as possible.
Okay, thank you so much. Dr. Sandy Popola is also here, and is very a very resourceful person. So we wanted to just give us one or two things before we draw the webinar to conclusion. So Dr. Sandy Popola, please, you have the floor now.
Thank you very much, Kay, and thank you, Rahul, for spending this wonderful time. I've tried to encourage as many children to come and listen to this, but it's good you're recording it so we'll be able to play back to them. This is something we've been trying to do since we started our initiative we call Creative Futures. In other words, start thinking of your future from now. It doesn't matter how young you are. And Kay and his group and many other groups have been supporting that for years. And we do a lot of things very similar to what you're doing. We get kids to build robotics. We get them to build bridges, teamwork, collaboration, things that you need in the next century. As you said, computer could do all the mathematics for us, but we want people with a creative mind, people that can think what to put in that computer to be able to get an answer out. And that's what you're doing. I really appreciate that. On my day job, I'm a professor at Imperial College London, structural engineering, nothing to do with coding, but I'm gradually learning, and I've learned a lot from what you said today. So I think we could synergize with our brother in Dubai as well, UAE, and with Kay. I'm sure there's a lot of things we can put together for Africa. Thank you very much.
Yeah, no, that's great. Nice to meet you as well. Would love to connect. And I saw a couple kids on the call, so it's just really nice to see that. So happy to help out if any of the kids especially have questions afterward. I'm happy to hop on a call with any of the children if they're interested.
What I say to my kids, don't be the one in front of the game, be the one at the back of it, creating the game. And then you become something. Yeah.
I love that. Yeah, that's great. It's a really good way of saying it.
Yeah.
Thank you so much, everybody. So our team lead, Mr. Dumoye Ayobami, will take the closing remark so that we'll bring the webinar to a close. Dumoye Ayobami. Okay, Dumoye Ayobami, can you hear me?
I can hear you.
Okay. Okay, you have the floor.
Okay. Good evening, everybody. I would like to appreciate the speakers so far, Mr. Rahul, Mr. SIJ, and Dr. Popola. For Mr. Rahul, thank you for the imparting knowledge to us here in Nigeria. We appreciate your time. And for our partners and the parents on board, to say a very big thank you. So, Mr. Rahul, we would love to look for more interesting and exciting session with you, by God's grace.
So thank you so much, everybody. Really appreciate your time. And it's 8:25 p.m. here in Nigeria. I'm sure it's almost 12:30 in California. Mr. Jimin Diabo, what's the time in Dubai?
It's actually 11:25 now. PM actually.
PM. Oh, okay. So
it's past your bedtime.
Yeah, time to go to bed.
So thank you so much, everyone. We really appreciate you coming. We have exciting things that we're doing at KidsTech Africa, and we are so happy that we've gotten a lot of people that are supporting us. We really appreciate all what you've been doing for us, our partners, our advisory board, and the parents and the kids most especially. We appreciate everybody. So do have a great day, have a great night, depending on the region that we are. So thank you so much.
All right, thanks everyone. If anyone wants to follow up, I'm pretty active on Twitter, LinkedIn, and YouTube. So feel free to connect. Happy to answer any follow-ups or chat further. But thanks everyone. Nice being here.
Thank you so much. Thank you.
Bye. See you all.